Okay, so we introduced the second type of improper integral, which occurs whenever you have a vertical asymptote, and we did one example, and now I'd just like to do another example to show you how this works. So again, if you have a vertical asymptote, then you can still calculate the integral by taking the limit. Now, you may not actually get a value, but sometimes you may. So here, let's do the integral from 0 to 2 of x times natural log of x dx. Now, you should remember that natural log of x is only defined when x is a positive number. So the domain of natural log of x is positive numbers. You cannot plug in even 0, let alone negative numbers. And so it doesn't even make sense to plug in 0, and in fact you have a vertical asymptote, because plugging in like natural log of something really, really tiny that's close to 0 but not yet 0, natural log of something tiny is saying what power of e gives you something really, really tiny. So, and so you're trying to get like e to the what is 0. Well, e to any power is never 0, but to get close to 0 you do like e to the negative 2, that's like 1 over e squared, that's kind of small, or e to the negative 100, that's like 1 over e to the 100, that gets even smaller, e to the negative a billion. So to get really small values of powers of e, you need that power to be very, 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 very negative, and that translates into saying that natural log has a vertical asymptote at x equals 0. So here the vertical asymptote, so here you actually have a vertical asymptote at x equals 0. Okay, so then we just have to sort of go through the definition. So then how do we deal with this? We take the limit as some parameter approaches 0 from bigger numbers of the integral from that parameter up to 2 of x natural log of x dx. Okay. And now we'll actually just use integration by parts to do this. So to do integration by parts, we will, I'm not going to do the full calculation, I'll just set it up for you, but it says that that thing should be u, and therefore everything else, this and that together, should be dv. And so using integration by parts, still inside the limit, it should be equal to u times v, and if, actually let me just set it up, let me just do it for you. So if dv is x dx, then if you integrate that, we get x squared over 2 is equal to v. And if u is a natural log of x, then du is 1 over x dx. And so for completeness, I'll just remind you that the formula for integration by parts is that the integral of u dv is equal to uv minus the integral of v du. That's called integration by parts. Anyways, so we have it all set up here. So we have our u, so the integration by parts says it's equal to uv, so the order is irrelevant, I'm just going to write it like this, x squared over 2 times natural log of x, that's actually vu. Now we have to divide at the two endpoints, s and 2, minus the integral from s to 2 of v du, which just cancels out to give us x over 2 dx. So you can check that that is what you get when you do integration by parts, and of course we can calculate this integral here, just using the power rule, it's not a big deal, x over 2, that just becomes x squared over 4 when we do this integral, the integral using the power rule just becomes the integral of x gives us x squared over 2, but it's already divided by 2, so that gives us a power of 4. Anyway, so when we're doing it, we get, we haven't done anything here, this is still x squared natural log of x all divided by 2, and then we're getting an x squared over 4, and we have to evaluate all of this from s to 2. So, we just do it. So again, that's the limit as s goes to 0 plus. So you first plug in 2. When you plug in 2, you'll get 4 over 2 is 2. And you get natural log of 2 minus 2 squared is 4 over 4 is 1. So that's from this part here, this whole thing here is from plugging in the s. Sorry, I misspoke, plugging in the 2. And then you subtract from it what happens when you plug in the s. When you plug in the s, of course, you'll get s squared natural log of s, that's an s, divided by 2, minus s squared over 4. Okay, and all of this is inside the limit here. So you're taking a limit over s, the only occurrences of s are right here. But as s goes to as s goes to 0, s squared goes to 0, so this thing clearly goes to 0. Now as s goes to 0, this part goes to 0, but this thing goes to negative infinity. And so you have to use L'Hopital's rule, and if you use L'Hopital's rule, you'll see that this also goes to 0. So both these goes to 0 as s goes to 0. And so when you actually take the limit, the contribution from the s ends up vanishing, and you just get 2 times natural log of 2 minus 1, which is a finite number. You have to, what does natural log of 2? You have to plug that into the calculator to see. And so let me just summarize the computation. So we started over here. We observe that there's a vertical asymptote at x equals 0, so you have to be very careful. You just go through it taking limits. And so, in summary, we have that the integral from 0 to 2 of x, natural log of x, dx is 2 natural log of 2.